Welcome back to Kamal Kunj Home Academy, Encounter with Mathematics. In this session, we will prove that square root of 2 is irrational. So, prove that square root of 2 is irrational. Now, if possible, let us assume that root 2 is rational. If possible, let us assume that root 2 is rational. And its simplest form is A upon B. This implies that A and B are integers having common factor only 1. Here B is not equal to 0. Now, root 2 is equal to A upon B as per our assumption. This like that, taking square on both sides, equal to A upon B whole square. This implies that 2 is equal to A square upon B square. This implies that 2b square equal to A square. Let this be 1. Now 2b square is equal to A square. This implies that 2 divides A square. Since 2 divides 2b square. Now since 2 is prime and 2 divides A square, this implies that 2 divides A. Because we know that P divides A square. This implies that P divides A. where P is prime. So using this result, 2 divides A. Now since 2 divides A, two divides A, this implies that A can be written as 2C, where C is an integer. Now putting A equal to 2C here in 1, now putting A equal to 2C, equation 1, C 1, we get 2B square is equal to 2C whole square. This implies that 2B square is equal to 4C square, and this implies that B square is equal to 2C square. This implies that 2 divides B square. Divides B square. Since 2 is a prime, this implies that 2 divides A, or 2 divides B. Okay. 2 divides 2 B square. So here we see that 2 is a common factor of A as well as B. Thus, we see that 2 is a common factor of A and B. Now this contradicts the statement that only factor of A and B is 1. Now this contradicts the statement that only common factor of A and B is 1. Now, this contradiction arises due to our assumption that root 2 is rational. This contradiction arises due to our assumption that root 2 is rational. Hence, root 2 is irrational. Now, we will stop here and continue further in the next session. Till then, goodbye and thanks for watching.